Okay, so in summary then, as the Earth goes around the Sun and experiences its seasonal variations, the tilt of the Earth's rotational axis remains fairly constant. So it goes around the Sun like this, then it gets to this point, and now this is winter in the northern hemisphere, but summer down here in the southern hemisphere. Then it comes around to here. On this side, summer in the northern hemisphere, winter in the southern, because you can see that in this case, the northern hemisphere is getting more light. But at the in-between points, here and on the other side, the Earth's axis isn't leaning toward or away from the Sun. So this then is the first day of fall in the northern hemisphere. Then here, this would be the first day of winter in the northern hemisphere. This would be the first day of spring, and then back to the first day of summer again. Okay, so if we look up at the data projector, we can see these different points. Here the Earth's axis is leaning toward the Sun. Here on this side it's leaning away from the Sun. But here it's not leaning toward or away from the Sun. It's not leaning toward or away from the Sun there either. And so I'm going to try to show that in this picture. Where again I'm greatly underestimating the size of the Sun relative to the Earth. But here, this is the first day of winter. In the northern hemisphere. First day of summer in the southern hemisphere. This is the first day of summer. Northern hemisphere. And we know that that means it's also the first day of winter in the southern hemisphere. But as the Earth comes around to this position, so that the Earth's axis isn't leaning toward or away from the Sun, we have the equinoxes. So if this happens, say, on June 22nd or so, then it comes around to this point, and it's in front of the Sun, I'm trying to show that here. At this point, this is the first day of fall in the northern hemisphere. But if this were the first day of summer in the northern hemisphere, it's the first day of winter in the southern hemisphere, then this would be the first day of spring in the southern hemisphere. So they're always off by 2 seasons. So this would be around September 22nd, be the first day of spring. Southern hemisphere. And then we come around to this point, and then the Earth goes, from our point of view here, behind the Sun, and then back around to this point. Remember that if you look down from above, you're seeing the Earth go around in a counterclockwise path. Then this would be the first day of winter in the northern hemisphere. This would be the first day of spring. In the northern hemisphere. Which would be the first day of fall in the southern hemisphere, because they're off by 2 seasons. Okay, and so these equinoxes then happen around March 22nd and September 23rd. And these numbers aren't quite exact because they do depend on whether we're in a leap year or not. And so those are the main configurations then that are associated with our seasons. Another important aspect of our relationship to the cycles are lunar phases. These lunar phases are caused by the Earth seeing different portions of the illuminated side of the moon each month. And so when we see a lunar phase, what we're seeing essentially then is the part of the moon that's visible to us from the Earth. But that being said, the sun can only illuminate one side of the moon at a time. So if the moon is going around the Earth like this, and the sun is out here shining its radiation in, then this side will be illuminated, this side will be in the shadow. Get up to here, this side will be in the shadow, this side will be illuminated. Get up to here, because the sun's rays are coming in from that direction, this side will be illuminated, this side will be in the shadow. We get to the full moon phase, now we're seeing the entire side of the moon that's being illuminated by the sun. At this point, we're seeing a larger portion of that. And then as time goes on during the month, we see different amounts of the illuminated side of the moon. So this point here, we would call a new moon phase. Whereas here, most of what we're seeing is the dark side, but we're seeing a little bit of the illuminated side. So it looks like what's called a waxing crescent. Here, see a first quarter moon. Now here, we're seeing more and more of the illuminated side. So this is what we would call a waxing gibbous phase. And here, this is a full moon. Now waxing here just means that the phases are getting bigger. Waning on this side means that the phases are getting smaller. So here we're seeing the other side of the moon that we couldn't see during the waxing phases. So this would be a waning gibbous. Last quarter. So here we're seeing this side. So during a last quarter, we're seeing this side. We're seeing the other side of the moon that we couldn't see during the first quarter phase. And then finally here we have a waning crescent. So that looks like the waxing crescent. That is the other sliver that we can see. So basically, from the Earth's point of view, then we'd be seeing the left-hand side rather than the right-hand side of the illuminated side of the moon. We'll go back up to the projector. We can kind of put this all into perspective with, and these slides I have on Canvas for you, so you can double check these, but you can follow through with how the moon is being illuminated by the light from the sun during each of these phases, what it looks like to you, and what the actual appearance is in the motion of the moon as it orbits the Earth. And here we're assuming in all the pictures that I'll be drawing that the sun is coming in from the left.